So we're going to jump back to the top. So we've been working with these quadratics. We learned a few things, but let's get some standard stuff down. First off, standard form. So there's more than one form for quadratics. We're going to mess with standard form the most. And standard form is y equals ax squared plus bx plus c. So there's also a point vertex form. We maybe mess with that if we have some time. But mostly we're going to deal with standard form where we have an a and a b and a c value. Okay? And these are corresponding to some things. We already found out, it was kind of fun, right? C value is the y-intercept, a lot like the b value and slope-intercept form of a line, right? And again, that's because when x is 0, those terms would be 0.
Why is b not the y-intercept?
Because in this case, there's three things happening. Yeah. So, these, remember again, these make Soldier Boy's favorite. A U-shaped curve. And it's called a parabola. The other place that I've heard, like, parabola out in the real world is, has anybody ever heard of parabolic flight?
Yes.
That's when they take the airplanes and they fly in a parabola and it makes weightlessness for a period of time to mimic outer space.
Oh, yeah.
It's
I've heard of that. Yeah,
Parabolic flight, yeah. So, when you sketched your first graph on the left from Decimal Graphing Calculator, I believe it probably looks something like this, right?
Yeah.
And the second one probably looks something like this.
Yeah.
Okay?
Oh, yeah. Oh, yeah.
So for A, the one on the left, A is this first value right there, the coefficient of the first term. Right here, when it is positive, how would you explain how it opens?
Oh.
Yeah, it opens up. Like a cup that could catch something, right? There's actually stuff you could do. Anyway, yeah. Then, when the A value right here was negative, what did you notice about your parabola? It opens down.
It's like a horseshoe.
It opens the opposite. A horseshoe can open up.
Okay?
Yeah.
So that's how the coefficient's going to mess with your parabola. The A value being positive, it's always going to open up. And A value negative, it's all going to open down. In fact, for me, most of the times I use a parabola in the real world, it's opening down because it's something called gravity. Yep. So the axis of symmetry is an imaginary line that passes through the vertex of a parabola. Left and right are mirrored, I'll say. Left and right are mirrored. So it splits it right in half perfectly. The left side's exactly what the right side is. We all know what symmetry is. It is the line across it. You also might hear like a reflective property. The line of reflection is the axis of symmetry is a line of reflection. It's pretty fun. And we do have a formula for this axis. The formula is x, I'm not writing it there. X equals negative b over 2a. So that's where those a, b's, and c's come in handy, okay? Here in alphabet soup. One more thing you need before we practice some things. When the vertex is the lowest, it is called the minimum. And when it is the highest, it is called the maximum. I have a quadratic formula here. I know it's a quadratic formula because I have an x to the second power there. Just to get organized, I like doing a little like my a value is 1, my b value is 8, and my c value is 15. I kind of just like pulling my a, b, and c values from my standard form. Remember, y equals ax squared plus bx plus c. And if you forget that, where can you look? Yeah, the top of your notes. So we know that the axis of symmetry equation is negative b over 2a. If you forget that, where can you look? Above in your notes. Okay. So, my negative b value would be negative 8. My 2a value would be 2. Which gives me an axis of symmetry of negative 4. So for the sketch part, one thing you can do right here, over on your sketch where you got to make one of these, I like to just like throw down my axis of symmetry like that. I know my axis of symmetry is right there. And I know what has to be on there somewhere. The vertex has to be on my axis of symmetry somewhere, right? So if I know that my x value for my vertex is negative 4, how could I find my y value? Yeah, plug it in, plug it in. Boom. So y needs to equal negative 4 squared plus 8 times negative 4 plus 15. What's going to happen if you don't slap that negative 4 in there in parentheses? It's going to come out negative. It's going to be wrong. So this is 16 negative 24, or no, 16 negative 32. For negative 16 plus 15 is a negative 1. So negative 4, negative 1 is my point. So everybody go with my vertex. Big idea for my vertex. I found the axis of symmetry. I used my x value to get my y value. Now which way does this one open up? Down or up? How do I know it opens up? It's positive a value. Also, I know that I have a y-intercept of 15, but that's going to be off my graph. But just, that can help you know kind of. If it was 2, just make it go through it, right? Because I would know that point pretty easy. So these don't need to be pretty graphs. I want to see that's opening up. I want to see that you got your vertex in the right spot. The next one I want to look at with you is number 6 on the back. Yeah, numero 6. Number 6 on the back. I'm going to just go to right hand so I take a picture. It's negative 3x squared minus 24x minus 42. So a value would be what? Negative 3. B? Negative 24. C?
Negative 42.
Okay. So the thing I can find is my axis of symmetry. What's the equation? X equals?
Negative b over 2.
Negative b over 2a. Notice I'm not shy about writing that. I just write that all day. It wasn't even hard. I'm barely sweating. Okay? So x equals, what's negative b? 24. And 2a?
Negative 6.
Negative 6. So my axis of symmetry is, again, negative 4. Right? My axis of symmetry is negative 4. So that means on my graph, I know there's an imaginary line right there through negative 4. How am I going to find my vertex? Yeah, I know that my x value is negative 4. Because I have a function, I plug that into my function, I should be able to pump out a y value. Be careful how you plug this in. Check it. Yeah, x is x.
But it's x squared, so isn't that like
Yeah, so right here I'm going to square it, and right here I'm not.
Isn't that like a different thing?
It's a different type of term.
But it's,
I can't combine them when it's just x, but once I know the number, I can just use order of operations. So negative, should I do this whole thing in my head? Let's do it. If I get it right, I'm doing a Ric Flair woo. You'll know it when you hear it. All right, let's do it. Negative 4 squared is 16. 16 times negative 3 is negative 48. Negative 48 plus 96. I got to get this out of my head, though. Am I allowed to do that?
no.
Negative 48 plus 96. Oh, that's 48. Minus 42 is 6. You guys get 6?
I just did do that. I haven't done it.
I just did the math. What do you think I was just doing, Nate?
No, I didn't.
Oh.
I was doing that.
Is it 6?
Yeah.
Whoo!
Oh,
I mean,
That's the vertex.
Wait, you did this lesson for second hour and first hour.
yeah.
So I just memorized the answer, but still told you every little step I did in my head?
Yeah.
Instead of just, no, that's not memorized. You're
What do you say
crazy.
you're gonna do if you got it right?
The Ric Flair, ooh. I just did it, didn't you hear it? I was going to sheesh, but I don't want to make it cooler than it already is, okay? See, yeah, you guys got the sheesh down. I don't need a sheesh for you. The only thing I want to point out, number 9 is y equals negative 2x squared plus 8. So help me out. What's my a value? What's my b value?
48.
Oh, I'm hearing conflicting answers. It's 0. That's why. Look what term's missing. The b. So c is 8. Okay, cool. Let's get after the homework's the rest of your PDF.